Hi and welcome to another Axual Release update. In this update we will show you highlights of the latest Axual Release 2020.2. But we would like to start with an exciting announcement. From this release we will start open sourcing more of our platform components, making them publicly available. Why we are doing this? As a software vendor we are relying on a great community for a number of our platform components, and we want to show our appreciation by contributing back. For you as a user of the software, it's easier to debug issues, report them, or even introduce your own fix. The first component we will open source under the Apache 2.0 license are the Java and .NET client libraries. For those of you unfamiliar with what those clients do, we will refresh your memory. As you know, there are multiple ways of getting your data in and out of your streaming platform, like Axual. Using a language-specific client is just one of them. You might remember this from another video we've posted. Now, when you're building your consumer or producer app, there are a lot of things you need to think about, such as: how do I send my messages securely? How should I handle cluster failures? Is my application idempotent? Or how can I guarantee ordering? When using a conventional open source Kafka client, you have to take care of this complexity all by yourself, potentially even repetitively for every app you build. The actual Java and .NET client libraries allow you to focus on the business value your application should bring and not too much on the plumbing that's often required. It offers interfaces that are easy to understand and hides the complexity under the hood. You will find the code of both libraries and additional components in GitLab, along with useful examples ready to try out yourself. Use the short URLs for easy access or the links in the comments section. In the future, you can expect more libraries and components to be open sourced, so stay tuned. Now let's have a look at what else Axual 2020.2 has in store. The value you derive from your streaming platform is largely defined by the number of streaming use cases you manage to onboard. Of course, you can do this in a conventional way, by implementing a producer or consumer in your app or by connecting with a REST proxy. Here you will have the full flexibility in designing and building your solution. If the data you need on the streaming platform is available in an external system, such as a database or message queue, you don't want to build, run and maintain an app for every peer-to-peer connection. Not only is it very costly, but it is also a waste of effort, as most of the complexity is related to the business problem you are trying to solve and not to the connection itself. This is where Connect comes in. Connect allows you to integrate Axual easily with external systems, to either load data to or from the streaming platform. There are more advantages than just saving time over a custom developed application. First of all, you can easily scale the number of Connect workers or tasks to accommodate for the load. Secondly, you can perform transformations or operations on messages, such as filtering, routing or masking. The way we look at connectors is not very different from a regular application. To us, an application is just a piece of software that either produces or consumes streaming data. This is why we believe our self-service concept for applications can be applied to connectors as well. This means the ownership of connectors is registered, and as a DevOps team, you can manage the entire connector lifecycle yourself. As of release 2020.2, it is now possible to manage connectors with the self-service interface. How this is being done, I will show you through a demo. In this example company, employees report IT incidents with a web app, which stores its data in a MariaDB database. This web app isn't actively maintained anymore, but the organization wants to make use of those incidents for advanced analysis in real time. In the future, the company might want to introduce additional functionality based on these incidents, so offloading this data to the streaming platform makes sense for them. The Advanced Incident Analysis app that needs the data uses S3 as a primary data source. I'm now part of the integrations team with Acme Corp to make this integration work. In essence, I have two tasks. First of all, set up a source connector from the MariaDB database to the incident stream. Secondly, set up a sync connector to load the data from the incident stream into the S3 bucket. I will now demonstrate how you can do this easily with Axual. I have now looked into the MariaDB database using the console. You can see that the table Incident Reports has a very simple structure, with columns Incident ID, timestamp, User ID, Severity and Report Message. As you can see, currently there are already 10 records in the table. The starting point is the app that loads the incidents from the database. I can create this connector app by creating an application named Incidents Loader and selecting Type Connector. After having selected this type, I can choose from various connector plugins, where I will now select the JDBC source connector, since I am loading data from an external system. I will now save the app. Apps can be configured per environment to give them a proper test drive before enabling them in production. For this demo, I will select the development environment. Now that I have created the connector application, I can configure defaults for the application that serve as a starting point when setting up the development environment before moving on to other environments. I click Configure, which opens up a modal in which possible configurations for this particular connector are shown. The configurations are shown as key value pairs. For the development environment, I will only add placeholders for the connection settings, as they are environment specific. But I am going to enter actual values for the following configurations. Timestamp column name, which is timestamp. Key converter, which is the JSON converter. Mode, which is timestamp. Value converter, which is the JSON converter again. Query, which is select star from incident reports. Topic prefix, which is the topic to write the records to. Of course, this is incidents. And then I click Save. Information on which configurations need to be set can be found in the connector documentation. Next step is to configure the application in the development environment. For every environment, I have to at least set up the application certificate, or PEM file, and the application's private key. First, I upload the connector's certificate to allow a secure connection with the platform. Secondly, I upload the private key. This is needed as the application will run on the platform itself. The connector's private key is stored securely using Vault to prevent it from ending up in the wrong hands. In the future, you can store more secrets in this way. I will now continue with the remainder of the settings, which are environment specific, and replace the placeholders. Connection user, which is Incidents Loader. Connection password, which I have copy-pasted. Connection URL, which I have already filled in, and another setting, value converter schemas enable, which is false. Then I click Save to save the configuration for the development environment. Now the only thing I need to do is request produce access to the incident stream, so the connector can store its messages there. To add a request, I click Add Requests. You can now see that only producer is available, since this is a source connector. I select Stream Incidents, as this stream existed already, and Environment Development. Then I click Request Approval. As soon as the request is approved, I can start to test my connector application in the development environment by clicking Start. You can see that the connector state changes to running. I can now click View Tasks to see what tasks are scheduled for this application and whether they are running as well. Now we should be able to see the 10 database records as individual messages on the incident stream. Therefore, we click to the incident stream and we open Browse and Search. We narrow the search to environment development and a wide enough time frame, which should give us the 10 database records as messages on a stream. I select development, I select the time window, and I click Search. And you can see below that the database records have ended up on the incident stream as they are shown as separate messages. As long as the connector is running, any new record in the incidents table should end up in the incidents stream immediately. Now that I have completed task 1, I will continue with task 2, which is to set up the connection with the S3 bucket. For the second task, I repeat the steps with slight differences. I create a new application, Incident Sync. I select the plugin S3 Sync Connector, as we are loading data to S3. We fill in the other details and I click Add Application. Now I set the generic S3 configurations, which apply to any environment. Those are timestamp.field, which is timestamp, the key converter, once again, JSON converter, format class, storage class, value converter, and topics, which is incidents in this case. Then I click Save to store the generic configurations. Next I upload the certificate and private key PEM files, and I set the configurations that apply to the development environment only. Those are S3.region, which is EU Central 1, and of course the S3 bucket name, where we want the messages to end up, which is incident.reports. Then I click Save. Now I only have to request consume access to the incident stream, after which I can start the connector, which I will do quickly. The only thing I have to do now is to start the connector, and it should be running within seconds. I can see that both the connector application and its task are in running state. If I now open up my S3 bucket, I can indeed see that the incident reports that I originally streamed from the MariaDB database ended up there. You have witnessed how you can hook up external data sinks and sources to Axual without coding anything. In this demo, you've seen 2 connector plugins, but we're planning to support more along the way. In our online documentation you will find a list of plugins we currently support. Apart from these new features, we have released a large number of bug fixes and improvements, which you can just check out by yourself. All of the shown features have been carefully documented in our online documentation, which now also offers an operations section, with more in-depth information for stream teams. That's it for now. If you're interested in trying Axual, sign up using the button. If you want to learn more about Axual, just visit our webpage or subscribe to our YouTube channel, or contact us directly at info@axual.com. For now, have a great summer!